Hello and welcome to the third segment on logic. In this segment, we're really going to go over truth values and what that really means. So let's get started. So one of the things we mean by truth value is the statement true? So we have statements like the cat is black, it is scary, it is night, it is Halloween, I love math, that are conditionally true. The cat is black for some cats. It is scary sometimes. It is night half the time are never like the sky is neon pink, my foot is 6 foot long, the unicorn stole my pajamas, math is bad for you. These things are all never true. And then we have statements that are always true, like 1 plus 1 is 2, math improves your brain power, and other things along those lines. So when we're starting to think about truth value, we're looking at the statement and thinking through our logical reasoning, is it true? Is it not true? So let's take a look at how this works in an if-then statement. So let's take something simple. If it is raining outside, then the football game is canceled. Well, that sounds pretty reasonable. So let's think it through. If I can break these into two statements, P and Q, P is if it's raining outside, and Q is the football game is canceled. And we can deal with each one of these differently. So for P, it is raining outside. That could be both true and false. Sometimes it is raining outside, sometimes it isn't. And then Q, same thing. The football game is canceled can be both true and false. Sometimes they cancel football games, sometimes they don't. So when we're looking at the truth value, we're thinking in terms of P and Q. So P can be either true or false. But when I look at it, the if-then statement with both P and Q, I know that P can be true and Q can be true, or P can be false and Q can be true, or P can be true, Q can be false, or P can be false and Q can be false. And I can think of it this way. So if it is raining outside is true. It is raining outside. And then they cancel the football game. Yes, the football game did get canceled. Or I can think, is it raining outside? No, it's not raining outside. But the football game still got canceled for different reasons. That makes PQ. Or true, it is raining outside, but they didn't cancel the football game. Or it's neither raining outside and they did not also cancel the football game. So the game is on and it's nice and sunny. So that's how these truth values work. And when we're thinking P then Q, we're thinking of when it's true for the whole statement. So if it's raining outside, that's true, and the football game is canceled, that's true, then the whole statement's true. It is raining outside and the football game is canceled. Now we have to think in a little bit of a different way. Because if I said, if it's raining outside and it's not raining outside, then it really doesn't matter what follows. Because if the first statement is false, the whole statement's true because of kind of a counter way of thinking. If it's not raining outside, I don't have to follow with my then statement. Then doesn't happen. So therefore, the whole thing is true. So that's why if the first statement is false, if my P is false, then the whole statement is true. Same thing here. If P is false, if it's not raining outside, it's the dependent statement, the football game being canceled, doesn't matter because it depends on me having a true statement to begin with. So if the first statement isn't true, then everything that follows doesn't really matter, so the whole statement is true. I know it's kind of a counterintuitive type of logic, but that's how it works. And it makes it a little bit easier when we put number statements in here, and you'll see a little bit better about how they work. So the only thing that we forgot about was down here, which is if it's raining outside, and that's true, but they didn't cancel the football game, that's false, then the whole statement is false. Okay? I also wanted to tell you about a little thing called not, because see this little doohickey here? This means not. Not P, not Q. What it means is the opposite of P, the opposite of Q. So if P is it is raining outside, not P is it is not raining outside. Or not Q is the football game is not canceled. So you're basically putting a not inside your statement. It is not raining outside. The football game is not canceled. And then their truth values obviously are opposite of the truth values of their original statements. Okay, so there's other things that go on here. So you can do like not P, if not P, then not Q. And later on in your book, you'll see lots of stuff like this, because there's a whole truth table to it where you're going to learn about converses and inverses and contrapositives and how they all work together, and how the truth values work together with that. But that you'll find out all about in your book. I just wanted to make sure you understood the very basics of this type of truth. So the last thing I want to bring up is how we really use these statements. So if I have something like, if it is a puppy, then it is black, I assume the first statement is true because I want to get into that true false for the whole statement. So let's assume it is a puppy. And we're going to do that in most of our true statements. We're going to assume the first part is true. So unless this first part is an absolute never happens, like if my foot is 6 feet tall, well, that's an always no. So the whole statement is goes back to the other truth values. But for the most part, the statements we use, we just assume the first statement is true. So it is a puppy. So if it is a puppy, then it is black. Since I know it's a puppy, I have to go, well, does that mean it's black? No, I can have a nice little white puppy. So this is kind of a counterexample to this if-then statement. If it is a puppy, then it is black. Nope, my puppy can be white. So therefore it's false. How about if the shape has 4 sides, then it's a rectangle? Well, there's a shape with 4 sides like this. It's a diamond or a rhombus. Then it is a rectangle. Is this a rectangle? Nope, but it does have 4 sides, so it's false. If you can find a counterexample to the statement, then it makes it false. So we're assuming the shape has 4 sides. So this we're going to accept as truth. So then we're going to judge this entire statement as false because we have rhombuses and diamonds. How about this one? If it is a rectangle, then it has 4 sides. Well, it has to be a rectangle. That's what we're accepting as true. So if it's a rectangle, yes, all rectangles have 4 sides. Therefore, it's true. Okay, you're going to try a little bit of these on your own. So go through and figure out if we assume the first part of the statement is true, the if part, then let's figure out whether or not the second statement is true. Okay, enjoy your afternoon.